students, up till here we have just talked about the magnetic field, like the field lines are here and they are not intersecting and such a kind of thing that denoting that certain kind of field is there. But what is this field? Okay, now let us talk about this field now, that magnetic field lines. Fine. So what is it? It is the region around the magnet, okay, where we are able to detect the magnetic forces of the magnet. Okay, let's suppose this is the magnet and the region that is covered by this magnet, that is influenced by this magnet, like any object that is around this magnetic field lines, like here, it could be anywhere, so it will get attracted towards it. But it should be the part of the iron. Okay, like agar aap yahan plastic leke आओगे, it will not get attracted toward the magnet. But the constituent, like a material which is having a constituent of iron, then it will only get attracted towards the magnet. Okay, so this is the region. Why I am calling this region? Because this is a particular space that is only get influenced due to this magnet. Okay, if anything that is outside this part will not get attracted towards it, it will not even get influenced because of it is not in contact with this magnetic field area. Let's suppose we are having an example here. I am having a horseshoe magnet. What is this magnet? What we call it? This name is horseshoe magnet. Okay, so this horseshoe magnet is having a certain magnetic field of itself. Yes, and here is an iron nail, and that iron nail is not going to be attracted toward it because it is out of the range. It is out of the region of the magnetic field. And when we keep it little bit close, okay, then it automatically get attracted towards it. Like it is get attracted when we keep it little close and when it is in the range of this magnetic field. So now we are able to say that yes, it is now get attracted toward it because magnetic field lines are influencing this iron nail right now. So that is the magnetic field lines and magnetic field area. Okay, so here what we have seen that the magnetic field is having a direction, so that indicates that this is a vector quantity because anything is having a magnitude and the direction, that gives us an indication of the vector quantity, as we have done this in 9th class. Okay, so here this magnetic field is also a vector quantity because it is having a magnitude, like the strength of magnetic field lines is here, because you know that a certain kind of magnet, even a small magnet, could attract a big amount of iron cube towards itself if the strength of this magnet is more. So this shows us the strength part is there. And direction, because you know magnetic field lines are going from north direction to the south direction, so direction part is also here. And even one more thing, that the outside part, the magnetic field lines are going like this, but inside it is going like this, from south to north. Okay, that we are going to study in details because after this we are having the properties of magnetic fields also. But for the now we are having the vector quantity because it is both having magnitude and direction, and the SI unit because you know that this is having certain magnitude. So that magnitude must be measured in certain unit because you know that liquid part, let's suppose we are weighing something, so we need to make it in kg, and if we are measuring the distance, so we are making it in kilometer. Fine. So if the thing is get measured, like how much the magnetic strength is here, whether it is more capable to attract lots of iron towards it, or whether it is capable just to attract small piece of iron nail, it depends upon the strength, and that is going to be measured into the Tesla. that is the SI unit of it, and it is given on the respect of Nikola Tesla, because he is the only one who has given the idea of magnetic field lines. Yeah, he was a very great scientist. I am very big fan of him. Okay, so by the now you just know that here Tesla is the SI unit of the magnetic field line, and magnetic field lines are get denoted by the capital letter B. Yeah, this is the symbol for magnetic field lines. So wherever you want to show the strength or there is a presence of magnetic field lines, so you can show it by the alphabet P. So students, as I have told you that we are going to see the magnetic field lines and observe it very briefly. So here we are having the important properties of magnetic field lines. Okay, so one by one we are going to see what are important properties of it. Here the first one is magnetic field is a quantity that has the both magnitude as well as direction. That I have already given you an idea that yes, the magnetic field lines in a bar magnet or any kind of magnet, because these are having two poles. Obviously every time we see that every kind of magnet, obviously there will be always two poles. So here also we are having two poles, and that poles from the north we are having a magnetic field lines generated, and it get inside into the south, and again inside it will going from south to north. In the similar way, lots of magnetic field lines are emerges and going like this. Okay, so this is the first. So direction is going to be indicated here, that in the outer part of the magnetic field lines it is going from the north to the south, and inside part of it from south to north. Fine students. Now see the thing here, as we have told you that the magnitude part is also playing a role. Why? Because you know that the strength part is covered. This is a bar magnet. Let me very clear to you. Okay, so lots of magnetic field lines are going like this, emerging like this. Okay, and these are the directions. So you know that here at the pole side we are having lots of magnetic field lines, and all of these are making a loop, big loop, and emerging into the south part. Now as you have seen here as the diagram, now you might have observed that in this way we are having the closed lines. Like here the very closed lines, the magnetic field lines are very close to each other in this case. And here in this case, in the middle part of it, we can see that magnetic field lines are far from each other. So when we are keeping the iron nail, and you can do that experiment at home also. So when you are playing with the magnet is here and a iron nail, and when you are putting it nearby to it, you will feel that when you are keeping it near to the poles, you will be feeling a greater force of attraction. And when you are putting it here somewhere in the middle of the magnetic field lines, you will feel a less amount of magnetic field attraction. Okay, that is because the closeness of the magnetic field lines. Whenever the magnetic field lines are very close to each other, this gives us an idea the strength here is more. We can say that magnetic field is here more, and at this place and this place, because they are very far from each other, so here the strength part is less. So it is clear to you now, because of the closeness and far of the magnetic field lines, this suggests as the strength of the degree of the closeness of the magnetic field lines. Okay, so this is the diagram, as I have already shown you this diagram, and here also you can see that here at the south and the north pole side the magnetic field lines are very close to each other, and at the middle part they are far from each other. Okay, now next property is magnetic field lines has a direction. Okay, that we have covered the first thing, and there we are having two parts. The first one is the magnitude, that is shown by this thing, that the poles are having more strength and the middle parts are having less strength. Similarly, in the way of the field lines direction, so I have already clear to you, I think, that here the magnetic field lines are moving out from the north and coming towards the south. moving out from the north and coming towards the south. And inside it, what is happening inside this? Inside this, we must have like this. Okay, we must have a parallel lines, parallel magnetic field lines. Outside they are making curve. It is a curve, but inside it, it is parallel to each other. And the direction is also get changed in it. Like outside part, it is going from north to south, but inside it, it is going from south to north. So this is again indicating one of the important property of magnetic field lines. So in this direction, as you can see in this diagram, the outer part is making a loop, and this is a fully covered loop. You are not just saying that it is breaking, as we have written here north and south. So it doesn't mean, it is just showing here for the name, so that you can see that north pole is here, south pole is here. Okay, but it is making a full closed loop, curve like this, and a straight line like this. A straight line inside it and a curve like this. Okay, so this is the magnetic field lines diagram. They are not going to break from one area or another area. They are just a continuous loop, and it is inside part of the magnet. It is parallel and going from south to north, and outside part of it, it is going from north to south like this. So the last property of magnetic field lines is the magnetic field lines do not cross each other. That we have already done in bar magnet case also, and it is a similar case in every kind of magnetic field. Okay, like what we have called here, we cannot have any of the magnetic field lines that are intersecting each other like this. It is not possible at all, because at this point now we are having two kinds of direction that is indicated by the magnetic compass, and that is not again possible because we are only having one south. If it could be possible, then which kind of south it is showing? Like let's suppose it is possible, and here when we are placing the magnetic compass, so it is indicating a direction of the south, so it must be directing towards any one direction only. It is not like that it is showing two direction at a time. It is not possible. That is why here we are having one south pole, so it is showing one south direction only. That is why we can call it as the magnetic field lines do not intersect or cutting each other. Okay, now what if I want to make my own magnetic field lines? It is just a diagram that we have shown here. Okay, if you are having a magnet and you want to plot your own magnetic field lines of that particular magnet, then you can do that also. So here is the thing, how to draw the magnetic field with the help of magnetic compass. Here we are having a diagram, as you can see. You can just place the magnet in the center of your paper and place the compass. So let's suppose here is the north and south pole of the magnet of yours, and we are placing here a magnetic compass. So now that magnetic compass is indicating particular direction, because magnetic compass is having a north point also, and that north point would get attract towards this south. You know that opposite faces of the magnet attracts each other. So the north pole of the compass will get attract toward this south. So it is pointing towards certain direction. Let us make a mark here. And the similar thing we are doing here, we have done here at this lower part also, as I have shown you in the diagram also. Okay, so now this point has been marked. Now we keep placing here the another magnet. This another magnet again give direction, and we are again pointing it like this. Now another direction, now another direction. Like this, all the direction that has been pointed by the compass is get marked like this. Okay, in the same way, it is get marked like this and making a lower portion also, because magnetic field lines are not just going here in the upper part. They are going in all around part. Even at this part, at the side parts also, but in a curved manner. Okay. But in the diagram, it is 2D diagram, so we can just show you like this only. but it is happening, dear all. When we are placing a magnet in the paper and we are connecting it with the magnetic compass, we will see that it is pointing somewhere. And when we are connecting all the dots together, what we will see? We will see that it is making a certain loop. And here also it is making a certain kind of loops. Okay, so now we can suggest that this loop is going from north to south, because north pole of this magnet is suggesting and making towards the south part. Okay, this is the north part, and the north of it magnet compass is also indicating the directions, and directions get connected and going towards the south part. So this is how you can yourself plot your own magnets field area. Okay, and like this I have made from this point, starting from this point. If you are starting from this point, so you will get this kind of field. When somebody is starting from this point, they will get this kind of field. So it depends from where you are originating, and obviously it is not like a single magnetic field line is here. It could be a lots of many more magnetic field lines and making a big hole. Okay, so loop is bigger, and at the north part we will see that it is a closer magnetic field lines. A lot of magnetic field lines would be here. That shows the strength. So here the magnetic field strength is more compared to the middle part. So do that experiment and other experiment that we have already discussed. Now coming to the next part of it. Now we have suggested all things about the bar magnets. Now let us see how electric current is generating magnetic field. So this is the main part of your syllabus, students, and all this till now we have just seen. It is all the introduction part, like, okay, because these are like students already known. Okay, but how the electricity is going to be making the magnetic field around it, that is the new thing for you people. And before that, magnetic field line properties you must get in your brain. Why? Because the same properties of magnetic field lines will be discussed in the next part.